is then maybe create a separate draft for, packet headers, or should we keep it within the ACL draft as it is at the moment? So I'm listening on the mailing list yesterday about sequence numbers, because right now the ACL was always ordered, by the sequence number, and they were ordered by the system. So the biggest problem in having a sequence number is how you can insert a new term if you didn't. At one point you will always run into the issue of you cannot squeeze a term between the sequence numbers, and you have to do the whole renumbering of the ACL. And we thought that by doing the sequencing by using it as a string and then ordered by the user, you can support both ways. If you want, you can just use numerical and then just put, here's the sorting based on the numbers, on the sequence numbers, and you're essentially getting the same effect. But then again, if you don't want to use based on the sequence number, you can just leave it ordered by the user, and then you can either have the longest match, or you can decide how you want to order, or you can also, based on the implementation, it can be changed. So those were any comments, questions?
Jürgen Schönwelder, I haven't really understood the last one. So is it going to be ordered by user or not?
Our suggestion is to be ordered by user.
Yeah, but that means it's ordered by user. It doesn't matter what the strings are. You can fool things and give it numbers, but you can put the numbers in any order, right? There's nothing that.
But you can then you can then do the sorting, behind once you are translating once you're saying you can sort them in the order you want in your implementation.
Why? The order matters, right? You have to have them in a certain order. So the order, that's why it's ordered by user, because the order matters, right?
Yes.
So I think we should not confuse people by telling them they can do something else, which doesn't really work.
If they're ordered by user, the system can't sort them by number.
Could you state your name, please?
Sorry, Phil Schaefer, Juniper. If they're ordered by system, then the system can't. You said implementation can sort them, but it doesn't work that way. My comment was if you're using if it's sorted by user, why stick with numbers? Why not move to names? Make something meaningful tag.
Well, we want to use the names. There was a comments to go back to the sequence numbers.
Okay. Well, I would be against using numbers for both of those reasons. One is it implies a sorting that you don't want to have, and the second is it's not flexible enough for people to actually put meaningful names on terms.
Jason Stern, Alcatel-Lucent. I guess what I was proposing on my comment there was a way to make it the model flexible enough to allow the two different types of systems to use the model. Because if you go with ordered by user and you want to stay with sequence numbers, that's different than using sequence numbers, which is implicitly ordered by the sequence number. So I proposed a couple things in the email on how to make that potentially flexible. One is the default in the Yang syntax is to be ordered by system. So if we leave that statement out, then other models can augment to add that statement back in, or surround that with make it optional in the draft with an if feature, so that because there are a number of systems that do it both ways out there, and it's going to be confusing for operators who are used to sequence numbers to you put sequence number 30 in and then you specify sequence number 10 and the order is the other way around. 30 is going to come before 10 in the current model. So I was looking for a way to be able to accommodate the mix of implementations that are out there.
Phil Schaefer again. I have to admit, I haven't seen your email, but I'll comment on that when I see it. But you can't augment a ordered by statement. You augment nodes.
Yeah.
AC Lindum Cisco? Yeah, I guess I'm next. AC Lindum Cisco. An access list since the beginning of time has an, implied ordering by sequence number when it's used. Now, when it's configured, I guess maybe I don't understand it completely, but that must be preserved or it's not an access list anymore. You can't call it an access list. You have to call it something else.
Well, no, the access list doesn't have to be, you can have access list longest match. It doesn't have to be by the...
That's not an access list.
Phil Schaefer again. My implementation since the beginning of time has used names.
Yeah.
Jason Stern here. So there's clearly a mix of implementations in the major vendors out there. So maybe an option for this model is to make an if feature around this one to say whether the list is implicitly or explicitly ordered.
Martin Björklund. So it's not possible to do that either. We cannot have an if feature on such a statement. But the other thing is, if the list is ordered by user, I mean internally, that more or less means that the position in the list is the sequence number. So, I mean it's fairly easy to map this to such an implementation, I would think.
Do we want to do show of hands who is for which option? Cheers.
So, could we have a, excuse me, sorry, I'm taking notes while you're up here. Could we have a raise of hands for the,
Just before we make that, is it possible that we're considering 3 options, ordered by system, ordered by user, or make the model somehow represent both?
Jürgen Schönwelder, the problem here is that somehow isn't clear. So a list in Yang can only be ordered in one way. It can't be ordered in multiple ways or implementation-specific ways. So I'm not sure where we are, what the proposal would be at the end. Have tool lists and but that sounds like not a desirable goal either to have tool lists. So I'm not sure what that would mean if we vote for support both, but then nobody knows how to do that.
Perhaps a solution could be to have a choice, and then you can put an if feature on a case in the choice, and then you can select. So there will be different names for user ordered and system ordered list, but I think that may be a good thing actually.
Did you say good thing or?
could you use the mic? The remote people can't hear you.
Jürgen Schönwelder, I didn't understand that. So where do you want to put the choice? I mean, the list has a property of being ordered. So where do you want to put a choice? Okay, so your proposal was to have 2 separate lists, and so to please different implementations. Come here.
Could you talk in the mic? Thanks.
Sorry, again, my proposal was to have 2 separate lists, but have them as 2 cases inside a choice node, and then perhaps use if feature for just making one of them unavailable. Things like that. There are a couple of options, but that's probably
3 options.
Yeah.
So let's ask the room now. We have 3 options, right? So who would like to do what Lotta just proposed? Sorry, could you repeat your, sorry.
I'm not sure if it's really my proposal because just one option that
Well, it's an
might be
option.
considered.
It's an option.
But the substance is that the data model would define a choice node and then two case nodes, each of them containing one list. And one of the lists would be user ordered and the other list would be system ordered.
So could you raise hands if you like this one? All right, we've got about five people, 6. Could you raise your hand if you're in favor of having system ordered? So, by sequence number. 2 people, okay? And then, excuse me, the third choice was by name? Only by name, yes.
This is ordered by user.
The first option had basically both cases. The second 2 options are one or the other. So raise your hands if you're in. Okay, so we've got 1, 3, 6. You got 6 or 7?
AC Lindum, I'm just going to say that if you just have the name be just a tag for the access list entry, and the ordering is different on, and behavior is different on different network devices in the Netmod or Netconf terminology, it's not going to be interoperable. I mean, an access list, if you send it to one device, it'll do one thing, and you send it to another device, it'll do another thing. So,
Okay, so from the sequence numbers and putting it in, it's not, you can go into 30, 40,000 entries, and if you have to do an entry in, and you end up doing renumeration, this is a very expensive operations, and the operators are expecting, I saw several operators who are expecting thousands of updates per second in the filters. Once you hit that renumbering, they're just saying, wait a second, this is not really what I wanted. And we have to get off this, old way of having sequence numbers and telling them, look, you can create multiple filters and put filters in orders. And then you can, within the access list, within the entries, you can then say, hey, you can create a filter where you will have, I don't know, the longest match, or you can have, filters with some, prioritizations. But we cannot, continue, sitting on this, access, sequence number, bandwagon. We have to introduce some other options, and
Right.
where this penalty the remuneration penalty will not be, will not be an issue anymore.
AC Lindum again. So everybody agrees, each access list will have a name. But you're saying each ACE, you want that to have a name instead to avoid the reordering problem. Okay. Well, you still have if you don't have a sequence number, how will this back-end system know?
Longest match of of the entry, for example.
Well, you have a source and a dest. Which is the longest match of which?
If I could for a second?
It just doesn't work.
Nobody's looking for a lack of interoperability. If you have names and you need numbers, you just number them by position. There's only your pretext that behavior will be inconsistent can't work, of course. If you need sequence numbers, you'd have to generate them based on the position of elements inside the list.
So Martin Björklund, also, the whole idea with an ordered by user list is that when the operator creates the entries, he gives the names and put them in a certain order, and that order is maintained across implementations and to the backend system, right? So the order in which they are defined, and you can move them around and all that, that is the order of, that they will be applied. So the order of the configuration statements, or if you wish.
Mike, please.
No, it's maintaining the device. But so you create them in a certain order, and you can, insert into that list at a certain position and so on. And that order is what's being used by the backend system. So if you send that list to another device, it's going to be sent in the same order, and that device is going to apply the rules in the same order. So again, it's not supposed to be non-interoperable. It's a way of specifying the lists. So
AC Lindum, maybe the draft should explain that, how it works. If we do go with a name per access list entry, or the ACE as it's called in the draft, maybe it should explain how the ordering is maintained without a sequence number.
Okay.
Jeff, I was just mostly for AC. I think the confusion that you're having is that user ordering means that it is inserted in the list in the order the user applies it to. The key name here is just an addressable entity to allow you to say, I'm talking about this entry, add, delete. That's all it's for. That's all, you could call it sequence number, you could call it magic number. It's just the token to get at the entry. Does that clarify things? Okay.
So then are you okay now with the original approach, if we explain that?
I believe so.
Okay.
Okay, we'll update it accordingly.
So could you take the action
Yeah.
to
This
clarify
week,
that?
I'll do that after the meeting today.
Cool, thanks. Are there any other comments, questions? No? Cool. AC or Lada? Core routing? By the way, if people are remote, the audio problems we were having should have been fixed. If they're not, say something on Jabber and we'll look at it again.
Good morning. I'm going to talk about the core routing data model that's already in its 17th revision. And as you can see, AC Lindem became a co-author of this draft. And I hope that with AC's help, we will be able to finish this work soon. Next slide, please. Because this document is really late. And from my experience, for example, from Sunday's Young Advice session, there is quite a few groups of people working on different routing-related things, routing protocols, MPLS, that would really appreciate having something to start from, something stable, and this actually should be the core routing data model. So in order to really make everything as smooth as possible, we decided to reduce the data model to a bare minimum, so all features that were somehow controversial or features that can be easily augmented later if it is desired. These features were mainly removed. Second important thing is that all the discussions took place in the routing Yang court mailing list. So if you want to discuss some issues related to this draft, please go to that list, because this is where routing experts and Yang people meet to discuss not only the thing, of course, but this is the important forum for this document. And we were able to resolve several issues, but some of them still remain open. Next slide, please. So the main changes that happened since the 16th revision are these. So route filters were completely removed. The idea is that a group of experts will be formed that will start work on developing a route filtering framework. And so such a framework, after it is developed, will be augmented into this data model. Then another change was that numeric IDs of list entries in state data were completely removed. Again, it was not very clear what the purpose is. It became part of the data model on request from some I2RS people, but again, it's important that such IDs can be augmented into the data model again if it is really necessary, and it needn't be present in all implementations of this data model. Also, before we had quite a few choices for next hops in routes, static routes, and as well as in routes in RIPs, including some recursive next hops, and because we felt this is another feature that needs to be developed and it will take some time, so we decided to just keep the choice there, but only keep 2 of the cases of that choice. And that means I will show it on the next slide. But all these more complicated next hops will be again augmented later after the routing expert decide how to implement this actually. Phil?
Phil Schaefer, Juniper. So I had 2 questions. One is, did you consider using feature in the model to pull these pieces out without actually having to make separate Yang models?
Yes, some of these things were conditional by using features, but on the other hand, I don't think it's a good design pattern to have a really big number of features in the data model. I don't think it's very expensive to have an extra module for some features. So
in some ways it makes it more readable. In some ways it makes it less readable. It's a trade-off. And the second one was this may just be my ignorance, but is the interface to routing instance mapping end to end, or why is it a leaf list instead of just a leaf? Can an interface be in multiple routing instances?
So which item is this?
The last bullet says interface has a leaf list showing assignments to interfaces to routing instances.
Yes.
Does that imply that an interface can be in multiple routing instances?
I will talk about that later, but essentially it's about the discussion where the assignment of interfaces to routing instances is supposed to be done, supposed to be configured. So currently it's done under the routing instance, and the idea is that in state data we want to have like the back links, so that if you look at the state of an interface, you can see what routing instances, or maybe just a single routing instance, that's another issue.
Yeah, but so that's my question. Is it one or is it n? Can an interface be in multiple routing instances?
Well, that's one open issue, and
that's an open issue. That I had the same. I have that issue with the model today. Okay.
All right. Is that issue number 5 then?
We
5.
Okay.
The original idea was that indeed it can be in multiple routing instances, and that's why we have this leaf list. But maybe in the end we will decide to have only one. But there are other aspects of this, so I will talk about that later.
Okay. AC Lendum. I was just going to say one thing about the next hops. one thing we thought we could never cover all the recursive cases, so we have to, we thought we'd leave that out. Now, as far as the multi-path, I might have left that in, but, I thought it was more important in this draft that we agreed on the basic hierarchy, the relationship between the routing instances, ribs, and protocols. That's the most important point, because that's the base on which all these other models are dependent.
Right. And because of the fact that we removed some of the more complicated next hops, that feature multipath routes was removed, and this is the last change that I already explained what it means. Next slide, please. Okay, so this is now how the next hop choice looks like. What we have here is only a simple next hop that can have just an outgoing interface or IPv6 or IPv4 next hop address. This is a bit confusing because it's not possible to have both at the same time. This tree diagram cannot really capture this fact, but don't get confused by that. You have either IPv6 next hop address or IPv4 next hop address. And then the second case is a special next hop that covers some next hop like black hole, discard, and maybe something else. And all more complicated next hop cases were removed and can be added one by one while augmenting this next hop option schema node. And this is for RIP routes, and the same can be done for static routes. That means for configuration. Next slide. There are still quite a few open issues, and some of them are open even between the co-editors, as you will be able to see. So the list of these open issues is here, and I will discuss them one by one. So next slide. First issue, and one that I believe is the most important one to resolve, is about some discussion that has taken some time already, about really the fundamental hierarchy of the routing data model. So on the left, what you can see is the current status of the data tree. So at the top we have a list of routing instances. Each has a name, and also each has a type, so we can have multiple types of routing instances here. And inside each routing instance there is a list of routing protocols. This organization, by the way, is used by Junos and also by Alcatel-Lucent, and as I said, also by the co-routing data model at the moment. But the industry also uses other organization, namely this organization has a list of routing protocols at the top, and routing instances are defined and configured inside the routing protocol. So it's sort of just reversed. So protocol comes first and routing instances come second, and this is of course used by Cisco iOS, Brocade HP, and Huawei. And what's important here is that in this case routing instance really means virtual routing and forwarding instance, VRF, whereas in the other case other types of routing instances are possible. One aspect of the routing protocol-centric organization is that what can be done is that some parameters that are defined at the routing protocol level can be inherited by all instances. So this way you can specify defaults that are used for all routing instances. And that's one feature that those people who advocate this approach really appreciate. Jeff?
Jeff has a question about that, since I've been behind in my mailing list reading. When the discussion was going on about this keying, was the point about multi-instancing a given routing protocol brought up? You know, for example, multiple instances of OSPF without necessarily considering that it's belonging to a VERF.
Yeah, but in fact, even before we introduced these routing instances, it was possible to have multiple instances of the same routing protocol, or at least that was the idea.
Okay.
So,
Thank you.
right. So this is really an important issue that can have far-reaching consequences, because it would really change the data tree in a very serious way. So Stefan Litkovsky tried to run a poll among routing experts about their preferences, but unfortunately he didn't get any representative feedback, only like 2 or 3 responses from usual suspects. So I think it would be important that you guys speak up here and tell us your preferences, so that we can resolve this once and for all. And the recommendation from the editors of this document is to stick to the routing instance-centric organization that we have now. Any comments, or shall we have some consensus call?
Phil has a comment. Hold on. Go ahead, Phil.
Actually, two. One is you need to not be asking us vendors, because you know what we'll like, but be getting input from the operators and from the users of the model. The second is I wanted to point out that one of the nice values of the model that we happen to be using in Juniper is that you can take a routing instance like that and essentially make it a jail for a user. And you know, if you come in a particular interface, everything you see, all the routing protocols and everything else, is contained by that routing instance. It makes it a real, essentially a true root of the network environment. It's a good feature.
Stefan Likowski from Orange. This is a very important issue, and I hope that we will be able to solve it this week. So please provide your feedback. In my opinion, based on what you said, Lada, clearly, based on the feedback that we had, the value added maybe of protocol-centric is this inheritance that you pointed. But we can do inheritance with VRF-centric in a more agile and a more beautiful way using templates. And this is really important to understand. We may be able, I think there was a thread on the coordination list about this. We can create a routing instance template and then being able to apply this template at different stage of the configuration. It's even more flexible than using inheritance. That's why I personally think that this VRF-centric approach is more powerful. Now, in terms of operational feedback, I launched also some poll internally within Orange to try to find out what's the preference for the operational team. It's very hard, because if you talk to people that are using Cisco CLI, they will say, oh, I prefer Cisco. If you take to Juniper people, they will say, I prefer Juniper. But there is no clear preference, in fact. But I think this inheritance point is really important, and I think we can make it better using the VRF-centric model.
Yeah, just one comment. My observation so far has been that really people that are somehow attached to vendors tend to promote their own stuff, of course, but operators in general could live probably with any organization. What they really want to have is some decision and moving forward.
Did you want to jump in on that?
It's a real quick one. Yes, although we did, this is AC again. Although in the call that Stefan ran, we did not reach a consensus. We did reach a consensus that the people from the operators wanted one way of doing it. And especially if the vendors didn't commit all of them to commit to doing it both ways. They did not want two ways.
Jeff, so I forget whether it was Netmod or Netconf last IETF that this came up, but there was a proposal that was effectively heading in the direction of reinventing, addressing multiple instances of a management plane on the same device, effectively like SNMP communities were used. You know, I think it might have been Netmod last IETF. And to my mind, that's really the analysis point we want to be basing this decision on. Is right now both of these models are perfectly fine for a single management plane managing multiple instances of these things on a system. It works perfectly fine. But once you start adding stacks of these containers together, the indexing scheme becomes a little bit tricky. And SNMP communities is sort of the hack that everybody uses to allow that to happen for multi-instancing things today. To my mind, the routing instance-centric version, somewhat in the vein of Phil's idea of jails, it gives you a way to sort of containerize multiple sets of these things all together. And in such a system where you have many instances of these things, it does not map cleanly necessarily to VRFs or routing instances or what Juniper calls logical systems, but it does nicely map to some abstraction of a set of these things. And much like the SNMP model where you have to use communities to disambiguate things today, you still require some external mapping mechanism to figure out what's attached where. But it does allow you to actually say this full set of things belong together, whereas the routing instance set of things makes that mapping much more difficult. You end up having like a 3-level table to get to there.
Okay, thanks.
Carl Moberg. So it would be very interesting to hear from people that are actually going to program with this. I think we're talking largely from a set of people that are used to typing things in. It would be very interesting to see the call flow difference for basic use cases. In my mind, the whole idea of a template is very odd when you talk to a programmer, right? There are few other places in the world in database style programming where you say, well, actually, I have a template in the data store because I'm going to use it later, right? So it'd be useful to see how this pans out for the actual programmer, because people are not going to be typing these things in.
Maybe I should explain what a template means. Essentially, it's supposed to be something similar as groupings in Yang, so that the idea was, or at least my idea was, to define a special type of routing instances or special type of routing protocols that can serve as a template, so you can put some common parameters there, and then the real routing protocol instances, say, could refer to this instance and inherit the parameters from it. I don't think it's anything really difficult for a programmer to implement.
It could be easily argued that that template should reside on the disk just beside the client, not on the router. Why would you have ephemeral storage on the router as a programmer?
Yeah, I think this, of course, has to be discussed, and I hope we will discuss it soon in the routing code mailing list, so let's go there and do it. I don't think it's really critical for this decision now.
Could you let Lilia to the mic? She's got to leave. So I asked Aaliyah to come because there's an effort that Aaliyah just kicked off in the routing area for modeling architecture, which is kind of related to this. So it's interesting.
Yeah, I'm sorry to interrupt really good discussion. I'm really happy to see this conversation happening now. I have two things. I mentioned it on the routing gang core, and I haven't announced it yet, but Benoit and I have talked about it, and we're chartering a routing area design team that's going to look at the routing, the Yang architecture or the meta model, how the different routing related Yang models are going to need to connect up, what are the common pieces, how do we take a hold of these lots of models and make them work well together, common groupings, etc. I don't see that, sorry, so that's one piece of it. There's another part which is also looking at common conventions for routing area models. I'm not sure if there's going to be specific conventions that only apply for routing, or if those are going to come back as feedback into Netmod with recommendations or thoughts about common conventions. And then the third piece the design team is going to be looking at is future extensibility, because the last thing I want is to have us in 2 years look around and say, wow, we've done really great work, and you've been doing really great work getting all of these Yang models together, and then we realize that the IETF didn't stop moving, right? We want to have a case where the future work gets incorporated automatically or easily with a clear understanding of how it's going to work into future Yang models, so it's not a, oh yeah, and then they're going to implement the Yang model sometime separate from features, right? So anyway, those are the three pieces the design team is chartered to look at. I expect to be sending out a charter soon. I'm just waiting for the design team members to give me feedback on it first. I don't see that work impacting this particular model. It's much more about how the different models connect up. So I know Tom is concerned about what the relationship is, and I think they're related but orthogonal.
Right. Thank you. I can only comment on the last extensibility item. I believe that this data model, as well as the other data models that the Netmod working group has produced, really the main concern was about maximum extensibility that's achievable in Yang. So I think that of course, for example, you cannot change a container into a list. That's one thing that's difficult to do. So it's not an absolute extensibility, but we really try to make sure that what can possibly be extended in the future really can be done.
Yeah, I think that Yang has a lot of really good extensibility. This is more about putting the rules and understandings and conventions around how to do so and when to think about it when you're developing a new feature.
Cool. Thanks, Aaliyah.
Yeah, glad to. Sorry to. Oh, wait, Jürgen has something useful to say.
Sorry, it was one other. Go ahead, Jürgen.
Jürgen Schönwelder, quick question, Aaliyah, before you leave. I think that's very wonderful news, because I was really concerned about losing track of what fits where. Is there a timeline in which this design team is going to work?
You want me to hold them to the fire right after they've agreed? Yes, absolutely, good question. There is so actually there's two pieces. One is, yes, I'm hoping to get this meta model out before the next IETF. That's the timeline I told them. Some of the other aspects may take more time. I'm told them I'm willing to have up to a year if need be, but what I really want is that meta model. Really, I wanted it 3 months ago, but since no one has time travel yet, I'm willing to settle for before next IETF. Oh, and the second piece is, I'm talking about this, obviously we're chartering this team for routing area related Yang models. That's not because there aren't lots of other really important Yang models that we don't have to figure it out. It's all about trying to bite off a small, I can't say small scope, a plausible scope of modeling to look at. I expect that there's going to be interactions, and one of the questions will become, how do you all want to handle the Yang models that don't fall into that? Can we get a type of meta model for those as well? But I want to at least get something moving now. Let's see how it looks, and then that will help inform how to get the organization better going forward.
Okay, thank you.
Cool, thank you.
Absolutely, thank you.
Okay, so context switch back to the.
So Rob Shakir. I want to pick up on something that Carl said, which is around how you interact with the models. So we should not think about people typing at CLI and what they're used to, because the whole idea here is programmability, right? And then what we need to be thinking about is, what's the operation that you want to do? How often do you want to go and check the status of an entire protocol versus do you want to check all the protocols that are related with something, like a customer? And so I think that the routing instance-centric model makes more sense because of that. I want to be able to pull, especially with state data, I want to be able to pull everything that's associated with this particular customer or particular instance that's something I sell, which is something that means something to me. Generally, the protocol in the box, the only thing that's common is I happen to use that protocol. It might be doing n different things that are unrelated to each other. So I think when we start, if we think in that way about what is the outcome I'm trying to achieve, then it guides us a bit more than, well, this guy over here likes to type at Cisco and this guy over here likes to type at Juniper.
Right, that's an important point, I think. Actually, that really, the fact that the data model doesn't look really like a CLI structure of a particular vendor doesn't mean that that CLI will not be able to work with the data model. It could be that such an implementation might have more work than other, but so far I think, and it's also written here, so Stefan said that the mapping of the routing instance-centric design to this routing protocol-centric design is possible. We only have to discuss the way how to do it in the most efficient way.
So that's a good point that was brought up, and I think at the end of the day, we're not going to be able to settle this today. We're going to need more operational feedback, because there's a sort of a push and a pull thing here between the devices and then the people that want to use them, which is always an issue, right?
Right.
But do you have a comment? Go ahead.
Yeah, so Rob Schick again. One point about that is, I know, Ladi, you said, this works late. Actually, we might not want to push it forward. We might want to say, this is stable, but let's go and get some experience with it, right? Because...
Right, so I'm going to address that in a second. Exactly. Do you have a quick point?
So now that we've spent all this time on this, I've looked at mapping in both directions, and I think for the routing, to map the routing instance to a protocol-centric backend is completely possible, and I've had discussions with many people about this. But I think, we can get this one done. The other issues are even more fundamental, so we need to cover those. But I was just going to make a point that you can map in both directions. I actually think it's easier to map from the routing-centric backend to a routing-centric model to a protocol-centric backend than from a protocol-centric model to a routing instance-centric backend.
Right. That's a good point. You can always do the mapping. The question is, what is the performance penalty and all that. But so I want to take a sense of the room. So who could you raise your hand if you're inclined to do the routing instance centric model? Okay. We got about half the room. A lot. More than half of the room. If you're inclined for the routing protocol centric, could you raise your hand? No. Nobody. Okay. Cool.
Thank you, and that's good because it means I can continue my presentation, because otherwise all the other issues would be moot, essentially. Okay,
cool.
Skip next slide and go to the...
Go ahead.
So this is the second issue, and it's about the placement of the list of RIPs. Currently, in the current data model, the RIPs are at the top level, so the list is really global, and the idea was that each RIP can be used by any routing instance that is configured or present in the system. But actually, up to revision 04, RIPs were per routing instance. And then I believe it was after a review by Thomas Morin, and maybe that was a misunderstanding on my part. This change was done in revision 05, but now it seems that AC and most people recommend to move back to this organization that's on the right. That means having the list of RIP really private for each routing instance. So I'm fine with that, and actually, unless there are any objections, that means unless somebody knows about a routing instance type that might need this global RIP, I think that we can go forward with this change and move to the organization on the right. Any comments? No. So next slide, please. Oh, there's one comment, Stefan.
Yeah, Stefan from Orange. For me, the left proposal does not really make sense. Because it's when you have a routing instance, sorry?
Do you mean?
Global, yeah, yeah. Because normally when you have a RIB, only one routing instance is able to really insert route in it. You cannot share it between multiple routing instances. You may be able to exchange some routes and connect different RIBs from different routing instances, but it is different. A single RIB can only be alimented by just one routing instance for route insertion.
Okay, fair enough. I think that everybody in the room agrees on this per routing instance list of RIBs, so we will apply the change in the next revision. Next slide. Oh yeah, we can. And now about RIB connections. Actually, currently, each RIB can have additional parameters that can be configured for it, and one of them is a list of recipient RIBs. That means a list of RIBs that can receive routes from that particular RIB, and AC proposed to remove this option of configuring these recipient RIBs. Next slide, please. Maybe this is just the arguments in the discussion. AC's position is that no, this concept is not needed. That routes are only modified, deleted, and added by routing protocols.
AC Lindum, Cisco Systems. You know, there still should be the feature to have multiple RIBs per address family, because there is this multiple topology routing that some platforms support. I mean, it's not a widely it's not widely deployed, but still, you know, my thinking is the base should be a RIB per address family, and the RIB contained in the routing instance, and as a feature, multiple RIBs. And actually, this implicit, I didn't know it, but Cisco does have implicit connections between RIBs as well, but it's kind of an obscure feature, and I'm sure we're not going to get, so it would be by, it's for the iOS XE VPNs. This VNet feature does have this, an instance of this, but it's very specific to that. And I think the Junos RIB group feature is very specific, you know, there, and so those would be better augmented with vendor-specific models.
Right, but Junos is not the only implementation that allows something like this. For example, the word routing daemon allows for configuring these connections between RIBs directly. Jeff?
Jeff speaking is the guy who has RIB groups. I'm perfectly happy having this removed. The modeling version of what we want to have is routing protocols need to be able to interact with RIBs. Routing protocols may need to be able to cross instances to interact with RIBs. You know, for example, an instance of a BGP peer and some master instance interacting with a VRF RIB, as one example. And similarly, RIB groups could be modeled as sort of this logical entity that is allowing for stuff to be passed from one RIB to another. So RIB groups in Junos effectively could be modeled as just another protocol, just sort of a pseudo protocol. So we're not concerned, I think, by having this removed from the model.
Okay, I think it's okay if you remove it, because again, this is one feature that can be added via augmentation if necessary, or in some form of RIB group implementation or something like that. So I think that any comments on that? Any objections against removing this from the data model? If not, then let's move to the next issue. And this is about, and that goes back to the point we discussed with Phil about assigning interfaces to routing instances. So what we currently have is that this assignment is done under each routing instance, and that was the point that Phil asked about. is that in state data for each interface, we also have these backlinks. That means references to routing instances that a particular interface belongs to. And again, a proposal is to change this into something different, namely to configure this assignment under inside interface configuration. That means augmenting the IETF interface module, and this is not present here. Of course, the option of having the backlinks from a routing instance to the interfaces is also possible. So I think it can be done either way. I think it depends on personal preferences, maybe on really the implementation of the routing engine, which one is better. So maybe next slide you can show briefly the discussion. Again, the point is that this essentially models the approach of in Junos, where in Junos, really, as you can see, for example, IP addresses are configured under with interface as the top level list, whereas the assignment of interfaces to routing instances is done inside a routing instance being the top level list. So it's nothing that would be our invention. It just I'm not sure if there are any really strong technical arguments in favor of either solution. Jeffrey?
Jeffrey Dunn from Juniper Networks. About your comments, assignments to routing instance makes sense only for layer 3 interfaces. That's not completely true. If you have some other kind of routing instance other than VRF, for example, you have some layer 2 routing instances, you can certainly have associate a layer 2 interface into the routing instance. Another thing about interface address association, I think it's possible that an IPv4 interface could belong to instance 1, and IPv6 interface could belong to a different routing instance. So it's really per address family.
That's right, but the point was that for some interfaces it really makes no sense to assign them to any routing instance. Like if you have a VLAN trunk interface, you really don't want to have these parameters there. So in this sense, I think that it's more clear that you only put interfaces that are supposed to be part of a routing instance. But again, I think that both approaches are viable, so it depends whether there is really strong reason to move to the one on the right.
On the other hand, there is, I forgot the RFC number, it's the IP extension to the interface, IP augmentation to the interface model. There you have IPv4 container and IPv6 container. So if you want to associate a different address family to different routing instances, you can do it in the v4 and the v6 container. You can do it that way.
Okay, that's a good point, actually.
AC Lindum, and that's where the actually that may be, except for dual stack protocols, that may be a better place for the routing protocols to point, if it's a single stack protocol, to the actual to that one, and that's what's being augmented for the proposed BRP model that'll be presented on Thursday in the routing working group.
Mm-hmm.
The one thing I think if we do have two lists, we have to have some guidance on where you augment things, because we can't have some models augmenting one list or one place and other models augmenting others. It'll just be confusing.
Okay, any more comments to this? If not, I think that we have to discuss it a bit in the mailing list, and I hope we will find a good solution that works for everybody. Next slide. Yeah. And this is just a corollary to the previous. In fact, again, it's about configuring IPv6 router advertisement parameters. And there was a discussion about this in the Netmod mailing list back in 2011. And there was no clear preference to either solution. So after that, we decided to do it this way. That means to configure these array parameters inside the interface list in a routing instance. Again, AC thinks that it should be done under inside the IPv6 container. That's part of the IETF IP module. I think it's okay, but again, as long as we keep routing instances in the data model, I think it can be done either way, and I don't see any really strong preferences to move to the alternative solution, because in a way these parameters are important for routers. We all know what happens if people start configuring these parameters on their host station, like their laptops here in IETF sessions. That has happened too. Okay, so I don't really know. We can of course move to the alternative organization, but I still don't see any strong preferences.
AC Lindum. Again, if we didn't have 7223 and 7277, then I tend to agree that it doesn't make any difference. But now that we have those and we have models augmenting those, that's one of my main argument against this. You know, if we would have defined everything on this new list, yeah, then it's 6 of one, half dozen of the other. But now that we already have this list, and we already have the addresses there, we shouldn't be defining the RIB. We shouldn't leave it sitting with an address that the semantics of it changed based on a list, you know, a reference in another module. The place where the address is defined should point to the actual routing instance.
Okay, so maybe we can ask some opinions on this.
Why don't we take that to the list? We're like 15 minutes over.
All right, okay, we can I think that's my last slide here.
Yep. Dean, are you next?
Thank you.
Yep.
Quick.
Just one quick one, Benoit Clay speaking. So the draft that we've seen is one of the foundational one. It's key to make it right, and I'm very happy with the progress. Now there are some documents that depend on that, like the IGP ones, right? OSPF, ISIS, and I guess the BGP one. So typically we want to have this draft stable, but I don't think we should rush to have an RFC, which means that it's written in stone. So maybe what you want to do is produce the RFC at the time that we're having those draft, depending on this one, published as well, so, you know, in a group. And ideally, you know, it's a typical thing that we want to have an IETF 93 hackathon, right, gaining some experience on how to implement that.
Yeah, I agree. I think we should have implementations of these things somehow before we move them forward.
I agree, and actually what's really important is to decide about all these issues so that the data model is really stable and people can start using it. And
yep. Dean?
In the box. Okay, thanks. I haven't seen the box on the floor. You know, reading that. This is a draft result of young coordination work group, actually design team. We are trying to put some semantics, how certain things should be called, because we are seeing a lot of modeling done, and we see configuration models, we are seeing service models, we are seeing business models, but there's plenty of, is this a service model or a business model, confusion, and people mix them up in some of the presentations. And I believe that if we would have a common nomenclature and a classification system for the young models, it would help us, tremendously in our discussions. Next slide, please. So as young is being used by more and more organizations, not just within the IETF, and it's being used outside. Being able to communicate within the IETF and also to the other organizations, and knowing what we are meaning and how the things correlate to each other would be very helpful. As mentioned before, this has been discussed within the Young Coordination Group, but also I had private discussions with the operators as well with some vendors. Next slide, please. So here's the, so I will have 2 layer model options, and in the first option, it's a very simple it's a 3 layers. You have a network element young model, and this is essentially your configuration models, which are describing the device capabilities. Then in the next layer, you have a network service young model, and these are, these are essential. It's a description of an end-to-end service that can be on one or more devices, and it utilizes a subset of features that are available on that, on a particular device to create such a service. And then these 2 models we expect to be, described in Young. And these 2 model types, we expect them to be, written in Young. And this is where we can do a lot of work within the IETF, because in the network element Young models, this is where the vendors can do a lot of work with, the input from the operators. And I would love to see the operators taking the lead in the network service Young models, where they would be, defining the service models and telling us, look, this is how we are using, this is how we are using them. And the business service models, I saw some groups within the IETF trying to get business policy models started within the IETF, and I think this is we are a wrong group of people and experts to work on business service models. Those should be developed by other groups where there's more expertise in, in that area. I don't expect them to be done in Young. You can do them in other descriptive languages. If they decide to do them in Young, I think we will run into some issues that we didn't foresee that we needed syntactically and semantically in Young today. So that is a whole new category of requirements that you might start receiving if you have to start doing business service models in Young, or if groups decide to do that. Next slide, please. The definitions essentially is you have a network service Young model, which is an abstract view in Young of a of a service deployed on one or multiple network elements. For example, we have the new L3SM working group, and they would be, or best, they would be working with the service models. And for example, the network element Young model is the base, that we just discussed today is the ACO, or the routing config model, or OSPF model that is being discussed in, for example, in the OSPF working group. We have posted some. We have actually posted another version yesterday where we have cleaned up some of the text, and we have cleaned up some of the graphics. Next slide, please. This is one of my other models, and this is how I was hoping to be able to create one. But this is an extended version of the previous model of the 3 layers. And what I wanted to say here is that I wanted to break up the service model into service model and the service components. That you can create a service component, let's say, you can break up IPsec service into multiple components and then, reuse them. But Carl said from his experience that there are essentially two models that people have implemented, with the third one being the BIS model, and this is the config model and the service model. So if there are some people who would like to see such a model, it is open for discussion, but based on the, Carl's experience, and he said majority of the customers were seeing basic config model and a service model. Next slide, please. This is the second dimension. Once we are layered, is it a config model or a service model? Then how will the models will relate to it? And you always have a vendor configuration model, which is the base, which describes all the device capability. And it can be in Yang, it can be in CLI, and it can be it doesn't have to be in Yang. But this, on the network element, this creates a base, what is possible to be done on that, on that device. The network element can decide to support standard Yang models like ACL, OSPF, BGP, all those basic standard Yang models, and you will find out what the models are supported by the network elements. And then you can have a standard extension. For example, you have, as an example for standard extension, could be route filters. This is a standard extension on the routing. You have a, you have a routing model, and then as a standard extension, you have a routing filter. Because it extends, the basic model. But then you can also have proprietary extensions to the standard Yang model. You can say, well, I'm using the standard ACL model, but I'm supporting some other batch conditions or some other actions that are supported in the standard base model, and I'm augmenting them with my own vendor proprietary extensions. And then on the parallel, you can have a completely proprietary Yang model on that network element, which can be either written by the, it can be either done by the vendor or it can be done by a service provider.
Mahesh Chetanandani. So, two comments. Back to the previous slide, I do agree with Carl that in general there are
Too complicated.
Two levels. More will be more confusing. But back to the slide we were talking about, this slide actually does confuse me a lot. So, proprietary extension to a standard Yang model in my mind would be a proprietary model, but that's just my perception.
You can take for example, you can import, you can use the ACL model and just augment match conditions. So I'm just augmenting a match condition with my vendor proprietary features that I'm supporting.
Benoit, let me give you an example. Whenever we looked at syslog, we looked at the different features of syslog in all different vendor OS platform, etc. It does not make sense to standardize here the full sum of all these features. So we have to take a subset of these. Now, as a consequence, we're going to have extensions done by vendors. So how you call that? Proprietary extension to standard Yang model, proprietary Yang model. It's a term, but to have a full solution, we're going to have some of these features not done here. If we would try to do like a 1% set of all the features, we would be spending years here.
Rob Shakir, I just want to comment on the many layers of hierarchy because I believe it might be inspired by something that I drew out a while ago. Actually, the important thing isn't how many layers there are. The important thing is setting the expectation that there's mapping between the layers and there's some abstraction through the layers. The exact number of layers you want and how that ends up breaking up really depends on how the operator works internally, right? So it might be that you have an infrastructure team that look after the base config for, say, L3 VPN, and then everybody, other teams augment that into their services. So from our perspective, at BT, then I could say that in one of my networks, everything's either some form of L3 VPN or it's a pseudo wire. And I want to have one set of designs that get configured onto my network, and I don't want everybody trying to go back and do another L3 VPN or another pseudo wire. So that's the reason that having more layers might work, because you have one team that then looks after those things, and then people above them that add on to them. But we don't need to get hung up on it. We need to expect that things might be multi-layered to be able to provide operational advantages.
Cool. Jeff?
Jeff Haas. As I've gone through some of the models for like BGP, one of the things that's become sort of obvious to me is that they're actually something that's in between a full-out proprietary implementation for augmentation for stuff and something that belongs to the base model. So if some vendor has for some feature some set of knobs that is shared with some other vendor, customers will want that to be the same knob ideally across implementations. If we were to do it strictly in a proprietary model, we would have basically two knobs across two different namespaces that cover the same thing. We are sort of in the need for...
Which is what we have today.
Yeah, and we're sort of in need of IETF to provide a playground for us to define these things where vendors have agreed that we're going to do something that really is common and that we want to allow more than one person to implement the same thing, whether we're going to require a RFC or draft to actually define what this thing is, or just simply say, here's the place for this to go. I leave that as an open question, but I think that's something that we really should solve.
Yeah, that's a good point. And, this was actually brought up at the Yangathon. Benoit and I and a lot of other folks were talking about this, where there is a need to extract sort of common components out of these models so that they can be leveraged across different models too. And then implement that same knob the same way across a platform. So that's something we should be looking out for. Yeah, go ahead.
I agree this slide.
What, could you state your name, please?
But I
could you state your name, please?
But I disagree up slide.
Your
my
name,
name
please.
is Ji Xiaofeng from Huawei.
Thanks.
I agree this future, but I discussion with up slide. Up.
You mean the first dimension, the previous slide?
No.
No, there's, no, it's the other way.
Going the wrong way. Hold on.
Oh,
Or one more, this one or the previous one?
Yeah, I am confused. I'm confused with this future. I consider service model and the business model and the network element model all is information model. But component is program architecture. Information model is have information model architecture. Component have a program framework. This is there are two different architecture. I hope I have provided a document for information model architecture in IETF work group. Information model.
So what are you asking?
Component
For us to, are you asking for
architecture.
Dean to look at that?
What is your question or comment?
What is the question? Yeah.
I consider have two architecture. One is a program for program architecture. One is for information model architecture. We need information model architecture. 没事，我们就说我们就是有两个，我们希望有两个 architecture， 一个是 information model。
I think he's saying he wants us to have an information model in addition to the Yang model.
Is that the...
Was that the...
So you want to have an information model in addition to the information model architecture? How they're mapping in something like that, or?
Yeah, he just give us a suggestion for we should give two graph for one for information model graph architecture. One another is for programming and component infrastructure. Just give us a suggestion.
Yeah, I think in general we've avoided doing that in these. It's seen as kind of an unnecessary step to have an information model and then
Go to the data model.
and then the data model. The data model is the description.
Right, so what I'm taking, Jeff Oz, what I'm taking from your point is that the very top level models do not get code to implement them. They are strictly a high level description of the architecture and how things fit together. So, as you made in even your first slide, the BSS layer, the 3-layer model, not the 5-layer model, that is not something we're likely to have Yang to implement and might actually be the wrong choice to do.
But I stated that. The only, the 2 layers are implemented in Yang, and the 3rd layer can be implemented in something else.
And I think that is the point he is trying to make, is that those layers that are clearly a higher level description of architecture and do not actually have code should be distinguished a little bit better in your slides.
Okay.
Yeah, I think what we've done is we've actually combined those things together in the documents. Like, we describe that in the models in text rather than having a separate information model.
I think there's 1 or 2 more slides if you just go. Yeah, so how does this, all, fit together? You have essentially the network element where you have all the models that are supported and then in the orchestrator, you have the service model, which is, essentially using the lower level information from the device models and puts them together into a service model.
Yeah, Kevin D'Souza, AT&T. I was just wondering, in my mind, I thought there should be some sort of an abstraction between the service model and the element. Because, generally, I would think that the service model would certainly want to be neutral from the element. And perhaps that's what you mean by the standard Yang model there. But if that's the case, you would have some instantiation outside the element also, perhaps in a controller or something like that, right? So.
But I can create the service model solely using proprietary Yang model. There's nothing preventing me to do that.
Right, but that's going to be really hard for us to map between a service and.
But it's your choice.
Sort of
This is your choice.
Right.
You have that choice. You can have a choice of just using standard Yang models, or just using proprietary, or doing a mix. It's completely up to you to make decision. We are just trying to clarify what models do we have at what layer.
Yeah, I understand the flexibility you're providing, but I just want to understand the acknowledgement of the fact that we need some sort of a neutral model also perhaps in the middle, so that we can map in a vendor-neutral fashion between a service model and proprietary. Just the place for that.
That is your standard Yang model.
Okay, but it'll have to be instantiated also outside of the element, right?
Why? You don't have to do that.
Yeah, in a controller perhaps, because then you don't have to...
No, because you have to know what device does support, and then the best place, this is a, network element model. So you don't have to have it doesn't have to sit there, but it describes the capabilities of that device.
No, but if the device doesn't support it, right? There are some devices, you can have a hybrid situation where a device may support a multi-vendor situation. Some devices support it, some don't, right? So you will certainly need that model perhaps. Yeah, so
Carl Moberg, you're way ahead of all of us. The decomposition step is still open for interpretation, and it's probably a nice field for further study, the actual semantics of the decomposition. See what I mean? I agree that that's not in scope of what we're doing right now, how that actually happens, or how to think about that. And it's probably something that we will eventually have to take on.
Yeah, I think that's also, Rob brought that point up.
Yeah, I think until
Same
that's,
point, right? Yeah.
Until that's taken up, it's going to be hard for us as operators to work through.
So one thing I'd recommend is you take a look at the model and get involved with these guys to give them your input.
Eric Osborne, Level 3. I can't say I followed all of that, but
this idea of the IETF defining a service really makes me nervous. I mean, I hadn't historically seen it in the MPLS and IP side, and I think not defining the service is what differentiates us from other SDOs who, here is the way. If you're going to do service models, they should be stubs, templates. They should be very clearly a minimal sort of here's a way to get started. I don't want to have to go to people and say, well, I do MEF such and such Ethernet, and I do IETF flavor of VPN service because I happen to have a data modeling language to describe
We didn't
it.
say that the IETF will define them. We are just saying, we are classifying it, and then we are, that we expect that the service providers will take the lead, being either within the IETF or with some other, organizations, because the language is used across multiple organizations, and we have to be able to name, same thing, same, not have different names for, for same things.
Yeah, this is just a taxonomy. I think
Okay.
he agrees with what you're saying.
Yeah.
They're not saying everybody here is going to do everything in that layer, in these layers.
Okay, as long as this doesn't lead to a proliferation of here's a million ways to define a service model that doesn't get passed into working group docs and then turned into RFCs. I mean, that's the feature creep I want to avoid. So I think we're good there.
Yeah, cool. But Benoit, did you have something to say?
To the point of doing services in the IETF, yes, that's an open question. Now, we created a design team specifically for that to see if the operators could agree on some functionalities to do an L3 VPN. They produced a draft in 2.5 months. As a consequence, we have a new working group approved on Monday, announced, I guess today, on L3SM, L3 VPN service model. I don't believe we should have all the services on Azure IETF, but a basic one like this, yes. At least it's going to provide us all information we need if we have the right building blocks on network elements there.
Alex?
So Alex Clem, just one observation. I think you have actually multiple dimensions that you probably should actually also distinguish. One thing is basically the hierarchy, element, network, service, and so forth. But the other aspect, which doesn't quite fit in there, is the standard versus proprietary. And I think it probably makes sense to distinguish them, because you have it here proprietary versus standard network element. If you are, but really actually it would apply to all the layers. You can have also standard or proprietary Yang module service models as well, whether or not we do them in IETF or not.
Oh, okay. So you want to show like a standard service model and a proprietary service model?
Yeah. Well, two dimensions, right? One
Yeah,
thing
yeah.
is basically the layer of abstraction, the other
So-
whether it's standardized or
Yeah,
proprietary.
so splitting the orchestrator level into two. That service model is split it into two boxes.
Consequentially as well, yes.
Yeah.
Mhm.
Okay. Fair.
So Rob Shakir again, I just wanted to follow up on what Eric said. The work that we did to try and get the L3 VPN model, I think there's two bits of value in trying to do that. It's to make sure that all the parameters that you would put into it actually map into something below, so it can actually get configured on the network. And then just as in this decomposition step, to say, if we do work that, then there's going to be 10% of your service, 50% of your service, I don't mind how much it happens to be, that's going to use a common decomposition across all operators. I certainly don't expect to be marketing RFC foo services to my customers, and that's why we should stay away from the higher levels as well, because I don't want to see us standardizing billing either. Doesn't feel like a productive way forward. But I think there is some value in trying to define some primitives that we base things on that can be augmented by each operator.
Eric Osborne again, just for the record, yes. Primitives are one thing, but nobody intends to market RFC foo, but we all know they show up in RFPs, right? It sounds like everybody agrees that we should not be defining services except maybe when we define services, and that fuzzy bit in the middle is what makes me nervous. But it's going to evolve, and we'll just deal with it as it comes up. Like, there's no other way to get there.
Okay, last one at the mic. We're running late. Go ahead, Phil.
Okay, well, then I should not, maybe this isn't an appropriate question then. Phil Schaefer, Mike, so there's a motivation between the vendors and the operators to standardize what conversation happens between their tooling and our equipment. What's the motivation to push the service modeling? Is it for tool vendors, for providers to push on tool vendors to implement the model? I mean, what's the motivation?
You mean on the service models?
Yes.
We just want to, have a taxonomy for it, that's all. So that if we are talking to MEF or we are talking to TMF, that we are, talking apples and apples.
Okay.
Cool. Well, let's continue the conversation on the list. Excuse me. Anise, you ready? While we wait for Anise, though, I think the point Phil brought up, though, is a good one, right? We should understand why we're doing service models, and operators have to get involved to make them relevant. I know it's not a pink box, but I know, I didn't write it. But please stand in the box, though.
Okay.
So people that are remote can see you.
Good morning. My name is Anish Sheikh. I'm going to be talking about some work that we've done in the Open Config Operator Working Group. This is basically a informal group of network operators that has gotten together to define a set of data models and also some other approaches for improving the programmability of networks. So data models and sort of the way we model different parts of the network have been the key focus so far. So I'm presenting on their behalf. This represents several months of sort of thinking. This draft isn't presenting a data model per se, it's more of an approach for modeling operational state data as opposed to the configuration data where we've put a lot of focus so far. So hopefully I don't have to convince anybody that this is an important problem. Operational state data is critical for all sorts of network operations, all the way from turn-up of devices to network planning, traffic management, troubleshooting, etc. This hopefully is self-evident to everybody. If you observe operational state with respect to configuration, the frequency of those operations in terms of configuration are relatively less frequent compared to the amount of time that we spend actually looking at the state of the network and trying to understand it and track it. Here we're really trying to think outside of the traditional SNMP polling style of monitoring the network and observing it, but moving towards a more streaming style where you can imagine getting data continuously from network devices or be able to subscribe to specific updates from devices and have those published periodically. And then, of course, the state data is generally much higher volume than configuration. So in most data models, even if you fill out the configuration versus the state portions, you'll see that there's generally quite a bit more state data that you care about than actual configuration knobs. We sort of created this taxonomy of operational state data. It's not necessarily something new, but there's a few distinctions from how this has been viewed before. The first type of operational state data is that's derived from network elements or negotiated through some protocol with a peer device. These we call sort of derived operational state. So an example might be the negotiated BGP hold time that two peers decide on. Right? So it's not something that operator sets, it's something that's determined by the device. Second is the sort of traditional set of counters and statistics that appear on all devices. So it's something like interface counters, number of prefixes received from a BGP peer. Those are the sorts of things that we're talking about there. And the third category is something that's perhaps less thought of, which is the operational state data that represents the actual intended configuration. So here the idea is that you don't always have the case where your actual running configuration matches what your intent was. Sometimes it takes time because of asynchrony in the system. Sometimes the value is unexpected because you might have multiple writers in the system. For whatever reason, there could be a mismatch. So it's very, very important to be able to monitor the intended configuration along with what was actually pushed to devices. So we actually want to try hard to use Yang to model both operational state and configuration. We see clear benefits in having all of this data in the same schema. So we could certainly go back to the world where we use Yang primarily for modeling configuration, and then we have some other schema for describing operational state. But having them both together in the same data model where they can be easily correlated has some clear operational benefits. But there's a bunch of limitations that we've run across in trying to do this in Yang. First of all, I think there's sort of a clear statement and focus in this area in terms of focusing on configuration. So our 6244 clearly states that the focus of Yang has been on configuration data. And in netconf, there's a close correlation, of course, between Yang and netconf, and netconf also blurs some distinctions that we're trying to maintain in terms of operational state by sort of only giving us a way to sort of say something is config true or false, which means you really have, either something is writable or all the operational state is sort of lumped into one other category, which doesn't quite give us what we need. There's also the fact that the netconf-centric view of the world, one day hopefully we'll reach the point where all devices support netconf or all devices support transactional semantics, but we're not there yet and we're not going to be there for a while. So we need to be able to live in a world that is both transactional and synchronous for those devices that support it, but also distributed and asynchronous for those that don't. Just as a side note here, I guess, one of the things that we've also observed is that there are limitations that have arisen from the close coupling of Yang and netconf. And I think there's operators in the group who are planning to use netconf and for whom that's fine, and other operators who want to use other protocols or transports for managing their devices, but see a lot of value in using Yang as a data modeling language for that. So to the extent that we can decouple these, I think it would be very helpful. I know that may be somewhat controversial for some folks here, but it's something that I think would be very useful. We also have the problem that there hasn't been any common convention described yet for how we structure operational state data. So if you look across the models, some of which are RFCs today and others that are drafts, some of them follow a certain convention of putting operational state data in one subtree starting at the root of the module, and then configuration in another set of paths, again at the root of the module. But other models don't necessarily do that. They might sprinkle operational state data throughout the schema. The problem with that is that there's no easy way to tell where to find corresponding operational state and configuration data without having the context of knowing exactly where that is in the model that you're using. So there's no convention for this. And when you put models together, so today we sort of think of models one at a time, but in fact, to build a useful system, you need several models working together. So when you start composing these models, and Rob is going to talk a lot about this in the next presentation, this problem is exacerbated because these paths then don't have any consistency. So the place where you look for operational state data versus configuration is different in different parts of your composed model. And then the last problem, of course, is that, and this is not really criticism as such, as just more an observation, most of the Yang modeling work that's happening today doesn't pay a lot of attention to operational state, right? The focus has been primarily on configuration, and we sort of say, okay, we'll return to operational state later when we finally have the configuration right. And by the way, we've done this also in developing some of our models, right? We've had to go back and make sure that we sort of consider operational state, but we're trying hard not to ignore it. So we articulate in the draft a number of requirements, after sort of looking across what we're doing operationally, and came out with this set that's sort of a summary. The first is one of the things I mentioned on the previous slide is that intended configuration has to be considered part of operational state. Right, so we have to stop thinking of operational state as just counters and statistics and what the device actually derives. That is certainly an important part of state, but there's another part of state that represents intended configuration that has to be included. Because as I said, intended and actual configuration can be different in many systems. And this is related to the next point, which is that we want to support both transactional and synchronous systems as well as those that are asynchronous. So configuration changes in those latter set of systems may be applied immediately, may not be applied immediately or atomically in all cases, right? So you may have cases where things become eventually consistent, or as I said, multiple writers, where you need to see sort of how the configuration is changing as multiple writers are writing to the system. And of course, there is also the case of transactional synchronous systems which simplify this, but we need to be able to handle both cases. The third and fourth are also related requirements. These basically talk about the need to separate, being able to address configuration and state data clearly but separately, and also retrieve them independently. And when you do have a transactional or synchronous system, that means that essentially when you write some configuration value, you can be assured that it's either applied or not, or if you get a success value, you can be assured that it's applied. That's the idea of transactional semantics. So when you have that case, when you read back state data, you'd like to avoid having to read back also the intended configuration, because it in fact matches the actual config. So in that case, you'd like to be able to read back only the state data that represents either counters or statistics or things that are derived on the device themselves. because otherwise the rest of the intended config becomes redundant, because you know that it's been applied. But there are, of course, the cases where the system is asynchronous, and then you do need the intended config as part of the state. And then finally, this last point about having consistent schema locations. So configuration and operational state data being in places that are easy to find in the schema without having to maintain external maps or context about where they're located is an important requirement. So being able to correlate configuration and state data should be very simple for a programmer, and being able to read intended and actual configuration simultaneously through the schema is also very useful in being able to compare. Imagine on an ongoing basis you're getting a stream of state data from devices. You're able to observe when the intended configuration matches the actual that you're observing. So being able to see those simultaneously is very useful from an operational standpoint. So we proposed a structure in the draft of how you might build data models that actually enable or address these sorts of requirements. So this is just an example container that might be anywhere in your data model. The idea here basically is to create containers that are separate for configuration and state data and are labeled accordingly. Right? So in the top of this model you see that there's a couple of leaves here that represent configuration data. Those same leaves are duplicated in the state part of the data as read-only leaves. This is the intended configuration state data. And then you have other parts of the state data which might be derived state that the network element generates. And then of course you have counters and other statistics. So these last two, we propose a Yang extension to basically label these as operational true or something similar to that, so that you could address the operational state data that's not part of intended configuration separately. For that case that I mentioned where you have a transactional system, and when you do a get on the state data, you don't want to also get the intended configuration because you can be assured that it matches what you actually push to the device. So this is a very simple example that's in the appendix of the draft. We have a more complete example in the draft that I would encourage folks to have a look at. But this is the general structure, and we've proposed a few design patterns for building structures like this. But you can see that by pushing the configuration and state all the way down to the leaves of the data model, it essentially makes it unambiguous where to find corresponding configuration and state. You can, if you think about how these paths look, basically you have an entire path in the data model, and at the end there's a config part of the model, and then there's a state part of the model. So it's very simple to sort of find correlated data in this case for the programmer. So obviously there's advantages and disadvantages to this approach. We've listed a few of them here. The advantage, of course, is that we think that it addresses a lot of the requirements that we put forward, right? So there are certainly cases that do require more thinking, but at a high level, we've spent a lot of time on this, thinking through lots of options, and we think this option does address a fair number of the requirements. One of the sort of biggest advantages we think is that this doesn't change when you start composing models. By pushing configuration and state data all the way down to the leaves of the model, you don't have ambiguity when you start composing, right? The location of the corresponding state and data information, the state and configuration information, is known without having to have any external context. It's deterministic all the time. I only have one more slide, Jeff, if you allow me to finish. Okay, sorry. And we think this is generally supportable by existing implementations, because if you look at the types of show commands, for example, that are available on implementations today, you have the ability to separate, the configuration data from operational state data. This is even supported in netconf, although suboptimally, in the sense that when you do a get, you would get, in this case, all of the intended configuration as well as the rest of the operational state. You don't yet have a way to separate the element-derived data from the intended configuration. There are certainly drawbacks to this approach as well that we do recognize. First of all, writing the models is certainly more work, right? So we've actually refactored a fairly large model, and Rob can attest that it was actually a lot of work to do that. If you start writing the model from the beginning, however, with this in mind, it actually is not so bad. And it does require modelers to follow a convention, right? So there has to be some agreement that this is a convention that's going to be used throughout models, so that when you start putting models together to build an entire system, the convention stays intact. And of course, it introduces extra containers into the paths. If you think about the paths to the data, you do have some extra containers in there, but we view that as a relatively small price to pay for the simplicity that you get in terms of being able to read and correlate operational data and config data. So essentially, these drawbacks boil down to a trade-off between the additional modeling complexity of building the models and the simplicity for programmers in terms of consuming the operational state data. We think that's sort of the fundamental trade-off that's being made in this approach. Here we go.
One more.
Thanks. And then finally, a few more topics for discussion, a couple of which we describe in the draft. One is we suggest a few design patterns for building these models, how to set up basic container groupings to make it relatively easy to do this, how to handle lists. Lists require some thinking in terms of how you have containers underneath a list. Some cases have state data without corresponding configuration. I'm sure we can think of lots of examples where there is state data. Counters are a simple example that don't have corresponding configuration data. There are other things in the models like that. We think that can be handled in a relatively straightforward way. It's described in the draft as well. We came across some implications for Yang itself in doing this. One is around how lists are actually built and the semantics around list keys. There's some alternate proposals for thinking about how list keys should be defined in the draft. Also, the restriction that Yang has today in terms of not allowing read-write containers under a read-only container. If you have explicit labeling the way we've described or proposed, some of these constraints can probably be relaxed without actually causing ambiguity or confusion for model writers or consumers. And then finally, some extensions that we've proposed to mark derived state versus intended config, as I mentioned before. There are certainly alternative approaches to achieving at least some of these requirements, if not all of them. So one is, instead of putting this distinction directly in the data model itself, using underlying data stores so that you have a single schema, but then you have different RPCs, for example, that would let you get at different kinds of data. So there's certainly some advantages to this in terms of modeling simplicity, but we think it's at the expense of additional complexity for programmers to actually consume operational state data. It would be nice maybe if we could flatten the schema a bit. Might be an alternative where you could get rid of one or the other of the state or config container. We've thought a little bit about that. It's not clear that you can do that easily given the existing restrictions of that Yang has in terms of putting read-write containers, not being able to put read-write containers under read-only. For example, if you wanted to make state be the top level of your model and just have configuration, since it's a relatively smaller part of the overall data, maybe be just a container in the model, or vice versa. And then finally, I'll just mention that we have a more detailed set of slides that go through a lot of different examples and scenarios and some NetConf-related examples at the link in the slides. If you'd like to see sort of the thought process that we had to arrive at this, there's some information about that in those slides. So I'll be happy to take questions.
So this is a good topic for discussion, but I would even think that if we adopt this, that this should augment the 6087, because this is the guidelines on how to model and review the existing models that are proposed.
Yeah, I agree. Well, there's two different sort of areas in here. One is how to model. One is also perhaps changes needed to netcode. Right. So if you go to NetConf and showing those guys this stuff?
No, but there's a few of those guys here. Hopefully we can have that discussion offline also. Yeah, please.
Hi, Norm Strolli. Just a question. So in the case of do we see this as a way to do error handling? So if somebody configures something, an orchestrator configures something, and it can't be applied because of out of resources or some other mechanism, do we see the derived state as a way to echo back? And is that then like a pulled RPC from the orchestrator? Is that the only way to get that information back, or are there multiple ways of getting error information back? And what if later on the configuration can be applied because resources become available? Is there a way to to reflect that state back?
Yeah, so I guess there's a couple of questions there, and obviously more than one way to do this. I think one vision for being able to do that sort of error, there's two types of error handling I think you're talking about. One is that, being able to see that there's resources available or not on the device before you're able to instantiate some new configuration. We view that as sort of what you would use as in terms of the streaming data that lets you observe state data that shows you those resources available so you can better predict your ability to actually configure something new. The other error case you're talking about is actually pushing something and then having it fail, and how do you get notification for that? So again, if you in an asynchronous system, for example, you may push data that's semantically valid and get back a success, but the way you learn that it wasn't actually applied is by observing the state data and seeing that it wasn't in fact applied. So you see the mismatch directly. I mean, that's actually one of the motivations for creating the data model like this. So you can see both of those things happen. In a synchronous system, it's less complicated, right? Because you will push the data and it will fail because resources weren't available or whatever, and then you get immediate feedback, which then you can respond to.
Eric?
Hi, Eric Voigt. I like the way this work is going. One of the questions I have is, you talked about system-level models and synchronization with multiple devices to ensure the consistency of the intended state. Have you talked at all or thought at all about how to make sure that the intended state is actually synchronized across the multiple devices?
Not really. I think we've focused more on the intended state sort of matching with the actual configuration, for example, on a given device. But certainly this would need to extend across multiple devices. I mean, the composition I was talking about was more in terms of across models that you're using to manage a given device. There's a need to basically have a more deterministic way to find this data. But you're raising a good point that we haven't probably talked a lot about, and we don't address it in the draft yet.
We can talk offline about that if you're interested.
I think Phil was next.
Phil Schaefer, Juniper. Can you talk a bit about the motivation not to use an additional data store? That's always seemed the obvious choice to me. Just making an operational state data store, you fetch from it. Essentially, all the read-write, the config true flag is ignored. You get a full hierarchy. Seems pretty simple.
Yeah, it turns out that it's not that explicit though, right? And it also is not that straightforward, I think, as we start to think about it. So I have to admit that we haven't thought all the way through the trade-offs between the two. But as I said, it is an alternative approach. One is that having it explicit in the data model actually doesn't require then the programmer to do special fetches to get certain kinds of data, right? You can actually get it directly from the data model simultaneously this way. The other is that in the data store model, it's not clear to me how you would actually address different data stores that way, right? The addressing the sort of the data that's returned is based on the request that's made. If it's a get config, if it's a get operational, right? So it's not clear whether you could avoid actually having some information in the path. Otherwise, you'd have to introduce some new header or some new type of REST request if you're using REST, for example, to address it. So I think some of those things would need to be worked out. But I'm not dismissing that as an option. But I think that we see advantages to having this distinction explicit in the data itself, as opposed to hidden in data stores where it requires the user to actually send different kinds of requests to get different kinds of data.
Benoit?
Benoit Claes. So thanks for sharing experience, much appreciated. Now let me ask a question to which I believe I know the answer. So what about the existing RFCs that we have already? Are you asking them to change them?
We haven't asked them to do anything yet.
Right, but I can see you coming, right?
But
yeah,
that's the obvious.
Anyway, so the thing here is that this is just a straw man. That's kind of the point of putting this up, right? There's the question about data stores, and there's, I think, a question that we want to ask about what's the instantiating protocol? Can we be sure that it has data stores? If we don't, then this is a nice way to avoid having to think about that in other protocols potentially in the future. But if we can't take what's been done in the past and say, okay, it doesn't handle this problem that we're asking to discuss here.
Well, you actually can. I mean, that was the point I brought up on the mailing list this week, right? Which, Benoit maybe might want to throw in his 2 cents. But there are RFC models, and the work you guys are doing is important, but it has the implication of having to reboot those things, which is okay. But we need to put that on the table, right?
Yeah, I mean, so I've done this exercise internally for some of the RFC models that we have. Yes, I mean, it requires some refactoring if we adopt this model, but I think it's more to raise the point that, as Rob said, here's a straw man of how this should be organized. We need some convention that's common that is agreed upon for operational state, right? Because that is really the problem that we're trying to solve here. We think this approach has advantages, but it's obviously not the only approach to this problem.
Jürgen, do you have a...
I'm Jürgen Schönwelle. I'm talking specifically about the data models that this working group has produced. I believe we actually paid attention quite a bit to operational state, even though that might not be as visible. So there are certain conventions that we actually followed, and that was not by accident, but because of trade-off decisions. So it's important to understand why we did things in a certain way, and find a way of, if there is a significant better way, so it needs to be significant better and not just slightly different. So if it's significantly better, then we have to also look into the cost of, changing that. So the trade-off decision is going to be a very tough one.
Sure. I mean, I think we understand that, and it wasn't intended. As I said, most of the ongoing work today doesn't pay a lot of attention to operational state, but the RFCs that we have actually have clearly tried to put operational state in them, in particular the interfaces model. So certainly there's been some attention paid. I think the problem that we started seeing was the convention that's being used in the current set of RFC models puts this split of configuration and state data at the root of the module. And that may be fine if you look at individual models. When you start putting all these models together and try to build some sort of sensible device tree, for example, that then these roots start to look a little bit arbitrary when you start to compose models. And then you need a lot of external context. So that was some of the motivation for sort of looking at that convention, but then trying to think about other conventions that makes that less ambiguous.
Yeah, perhaps this stuff can be used as input to the wider effort.
So Carl Moberg, I'll bring up my favorite topic again. I think it would be useful to have a programmer's view on this, because you guys are heading towards state synchronization. And of course it's implied here that the synchronizing once is okay, you just check that your config in your intended state, but that state may change over time.
Sure.
So it would, which implies also asynchronous signaling or something like a netconf notification or something like that. Would be very interesting to take a look at that from a programmer's point of view.
Yeah, no, we've thought a lot about that actually, Carl. So I think this pub/sub model that I alluded to, we kind of have a set of requirements around monitoring that involve more than just polling devices, right? We need asynchronous notifications. We want continuous streaming, ideally, with incremental updates. So as you said, I don't want to synchronize everything on every request. I want to get just the things that have changed, right?
Jeff, so yeah, you started to make the point I was going to make about get not being good because you get operational state mixed with config state.
Gets everything.
And I think structural separation is probably the way to go with things. And the nice thing is, for people who have done SNMP modeling, it's what they're used to already. The question I have for you is, you did take the observation about get to the conclusion I was hoping you were, which is there are some cases where lumping the operational state inside the config state is sort of a convenient thing, both for the model and for the consumption. Is perhaps the right answer to have a request into netconf to add a get that is get just operational state?
Yeah, I mean, that was part of the motivation for introducing that extension. So if you can mark data and make these distinctions, then you can, by extension, add RPCs to netconf to address that data that you actually care about. Yeah, that's another approach. But again, I think the problem with that approach that we probably need to debate is that it does sort of hide the distinction of the data inside the data stores, as opposed to making it explicit in the model, if you rely on the data stores to make those distinctions for you.
That distinction is normally due to the config false marking, so it seems relatively clear. I guess sort of the related follow-on to this is that for your operational state, especially for the ability to sort of take multiple roots worth of data that are somewhat disparate and sieve them together, part of what's probably needed is some common practices for defining foreign keys intentionally inside of the data to allow them to be cross-correlated across the different models.
Yeah, I mean, or we need some agreed upon common structure that these models fit together in, right? So yes, I mean, I guess references across models might be one way to do that. But
Common indexes.
yes.
Sorry, we have one question on Jabber, and no more folks at the mic. We've got like one more minute.
All right. It's a comment on Jabber. I don't want to butcher the name. Says finding state data for a specific config item is a problem for Ericsson as well.
Xifeng Liu from Ericsson. A question about your convention to do the read-only states. Have you tried to implement your model? So the proposal you put there will have a significant implementation impact, which will make the implementation harder and the performance slower.
So we are actually in the process of implementing it. I guess I don't fully follow your point about the performance implication if you can do, for example, incremental updates of the state.
So for each read-write container, you have to implement the class. You have to have a database to back it up. So for that kind of a class, so you have a linkage to the database. You need to write into the database. For the read-only state, you can just read from the backend.
So the contents of those two sets of containers aren't the same data, right? I mean, they represent the same data, but they're different values potentially. So they would come from different data stores or databases, I guess.
Right, you're trying to mix them together.
Well, not really, right? I mean, we want to make sure that we're representing what's been pushed as configuration, the read-write part, with what is actually running on the system, which would be in the read-only part, right? Those would come from two different databases, presumably.
So that's what I'm saying. Have you fully implemented that?
Well, we've been trying to implement it on the consumption side, certainly. On the implementer side, we're actually starting to talk to implementers now of devices about this, yes.
So when we're trying to implement it, we pretty much give up this kind of a mixed read-write and read-only implementation. We don't want to do that.
Maybe we should talk offline, because my impression, or after discussing with the other folks in the team, I mean, this sort of separation is maintained by most devices today anyway. So it's not that we're introducing a new set of data that needs to be maintained, for example.
So this is exactly the conversation we should have on the mailing list.
Sure.
About this. This would be fantastic. Mr. Voigt?
Yeah. One thing is there's a pub/sub requirements document that was adopted by the ITORS across working groups. And for an advertisement for the NetComp group, we're going to be asking Alex and I for adoption as a working group draft of a pub/sub mechanism in the next session just after lunch.
Cool. And really briefly, we're on.
Yeah, Stefanikowski, Orange. I just want to mitigate something that you said about modules that are creating this hierarchy at the root of the module. This is true for some modules, but especially for routing protocols, ISIS and OSPF, we wanted really to not go into this, and we are just augmenting the routing states that is already existing in the core routing module. So this approach of taking just having two branches at the top, so config and state, this is something that could work also. And so all the modules can just augment these branches.
I mean, if modules are written in such a way that those groupings can either be imported or are augmented, but then the question is, where do they augment into, right? They have to have a defined place to augment.
You just create a reference design when you have these top modules which are state and configuration, and other modules just need to augment them. It's another possibility. I'm not saying that it's better or not. It's another possibility.
Yeah, just one quick comment. By the way, we did actually think about the alternative. So there's really only two unambiguous places that you can put split. One is at the end of the path, and one is at the very beginning of the path, right? So at the very beginning of the path, the question becomes, what is the very beginning of the path?
It's config and state.
No, what I mean is that you have lots of different models potentially now. I'm putting them together. I have multiple routes in my... If I just take them as is...
No, you must not have multiple routes. You have only one config and state, and then all the modules must fit in.
Okay, guys, can we take this to the list? We're out of time.
Sure.
Sorry.
Thanks. Thank you.
Who's next? Mahesh? Rob. Yeah. While Rob comes up, has everybody signed the blue sheets in here? If you haven't, raise your hand, please, and pass the sheets back. There's some in the back. Thanks. Rob, can you do this in like 5 minutes?
Yes.
Thanks.
So I'm going to talk about something that Anise alluded to a bit. Hopefully I can skip through some of it because we've already kind of discussed it. This is an effort that we started maybe back kind of October, November time because of wanting to try and build something that works as a whole, not necessarily a kind of bag of bits of models. So get the next slide, please. As we all know, numerous modules being defined, lots of them sort of define themselves as being right at the root. We've got kind of structure of config across the different models isn't necessarily consistent. We kind of have sometimes, it's kind of as Lada was talking to in the routing model, do we have stuff under interfaces? Is there stuff under a protocol? And there's not kind of a real clear way how that might fit together. In addition, the kind of models don't really have a granularity. So there's a model for LSP ping, for instance, and then there's the routing config model, and it feels like there should be more commonality with, say, other OEM mechanisms with LSP ping, that it might not need to sit by itself under its own module. So we wanted to try and look at what would a logical structure for models kind of look like, put up a straw man that's what's in this draft, and try and then use that as a way to kind of build an overall model that we can interact with as an operator. The other motivation is when we start to look at services, without some form of structure, it's quite difficult to know where things are going to map to in the overall hierarchy. So we wanted to start thinking about, for that decomposition of a service model into the underlying configuration models, how would that start to look? And when we look at, I want to actually configure a service, what would it impact? So the next slide, please. What we tried to do, and I think it caused a bit of confusion, was put what essentially is this picture, which you can't read at all, but that doesn't matter, into a Yang module, because it kind of felt like the right way to present it, and obviously we couldn't put this diagram in a draft. So the module that we've put together isn't really intended to be used by anything. It's just meant to be illustrative, insofar as you can put it through Pyang and get a tree to have a look at how that might lay out, not necessarily need to know anything else about it. Next slide, please. So yeah, as I say, the intent is to put forward a straw man for discussion. Does this look like a logical way to lay out things? Is it what would the changes to existing modules be, if there are any? Is there any feedback that we should take into account? We're not intending to be exhaustive.
Why don't you intend to be Dan Bogdanovich, why don't you intend to be extensible?
We do intend to be extensible. We don't intend to be exhaustive. Sorry, the wording on my slide may be confusing here. Essentially, we don't intend to have to do everything just from an operational perspective. What do we configure in the various operators that are looking at it, and look at it from a vendor neutral way, as in from our point of view, how would we like to interact with the models? I kind of made this point about the illustrative nature of the model. The other thing we haven't thought about and was brought up on the list is how would it actually be implemented any protocol. That was sort of outside of the scope of our thinking at the moment. I think it's definitely an important thing that we need to look at though. Next slide, please. So the tree that's in the module, in the draft, sorry, we didn't necessarily put the entire tree in it, but how it kind of splits down is some high-level device, which we've chosen as the kind of root of this model at the moment, with then the different sets of functionality underneath it. Sometimes not on a per protocol basis, broken down into more logically similar bits of configuration, like statistics collection. So things like IFIX and maybe other stats collection mechanisms that in the specific box might support would sit in there. And then interfaces, logical routers, which I've expanded out, which then has some grouping inside that model for things like layer 3 protocols and layer 2 protocols, so that you can start to get some reuse of things. So, for example, under some of the IGP, under the layer 3 protocols element, we don't necessarily have OSPF ISAS, we have IGP, and figure that there's likely to be some common config between those two things, and then have under IGP some OSPF specific things, some ISIS specific things. You can see for the MPLS work, we've published this consolidated MPLS model draft, which is kind of our thinking about how inside that MPLS container you might end up with some of that commonality for constrained and unconstrained paths. The way that you actually structure this and we build them into a model is an area that we tried to discuss in the draft. So you kind of end up with two approaches. This pull model, where you build an overall model and it includes groupings from all the other models that let you build it over into the overall hierarchy, or each individual model just provides an augmentation to this model. And we kind of haven't made any conclusion on this. Obviously, there's pros and cons of each of these. What we'd kind of like is a hybrid between the two, where if you wanted to run a module as an individual module, then you can do, but if you want to include it in the overall tree, then that's also possible. That's probably got some requirements on Yang compilers going forward, but we think it's worth a discussion in this kind of overall structure, model structure discussion. The other area that Kevin provided us a bunch of thinking on, and we've discussed as well, is looking at how we start to have a view of what models actually exist. So we know that there's going to be things that are going to be outside the IETF. So the Broadband Forum's already started on some of the 5 definitions. And we wanted to just kind of look at how that might, how we might understand what models are available, where they come from, etc. And so that's likely to be useful in an overall service model. So at the moment I can't build a model for my broadband service without including both something that's from the Broadband Forum as well as from the IETF.
Andy Bierman, I
Really quick.
I really
You've got,
agree
like,
with
30 seconds.
the problem of classification, understanding how modules fit together. The concept that where the module is placed in the tree provides some sort of cohesion, some sort of classification system that I think is really flawed. I think we need something completely different so that where the data lives in the tree is going to be somewhat irrelevant. It'll be important for retrieving an entire subtree, but what is in that subtree, is there going to be more classification tools than this to correlate things?
Certainly welcome suggestions. I don't think we can claim to have thought through every issue. I think that was the last slide, right? No, one more. Okay. So yeah, we actually think that having this well-defined structure from a programmer implementing something to interact with the models is pretty critical, and also to make sure that as we build these modules, we don't end up with duplication or inconsistencies across them. Obviously, Alia talked earlier about already starting to look at this in the routing area. Stefan started some of the debates about key issues inside that, but then also as Andy kind of raised, I guess, and we want to start a discussion about the specific other things that we need to take into account are. So does a module structure need to think about how you exchange capabilities, which bits are supported, which aren't, and whether those things are protocol specific. So this is not a complete bit of thinking. It's another bit like the previous draft of straw man of, well, we've had a bit of a think about it. It'd be great to get wider comments on how this looks, and comments on whether having a structure does have usability. I think from our perspective it does, but maybe there's some disagreement about that too.
Okay, we're out of time. Could we continue the conversation on the mailing list? Mahesh, are you here? There we go. Got 5 minutes max. So if you want any conversation,
I'll try to make it 2.
make it 2.
All right, so I'm going to just go these topics. Next slide, please. So the 00 draft was presented by 2 authors from Cisco, and then they asked a team to be expanded to include the other vendors. So we came in to kind of give it more perspective of how other vendors are implementing DiffServ today. So we have had these meetings, and out of that has come the 01 draft. So let me quickly go over some of the changes in that. So we have added some more filters and actions, and we try to make the model a little more flexible. And instead of trying to boil the whole ocean with all set of DiffServ features, at least started with a limited set of Yang features of DiffServ. As far as statistics are concerned, today they were in the 00 draft a global set of counters. So we're trying to move them to per interface counters. Next slide. So from a flow label perspective, we did add that as a filter parameter in the classifier entry module. Next slide. And as far as actions modules to policy, additions to policy is concerned, we did add ECN and double red profiles. Next slide. So from flexibility perspective, we said they're flexible because the classifier entries and the corresponding actions can be directly configured under a target. And the classifier entry can be defined through a template or can be configured inline. They are available as feature configurations, and for example, the child policy and random detect are separate features today. As I said, minimum set of features exposed. Next slide. So the advanced queue management currently has been defined as a leaf and only for leaf nodes. We do need to look at non-leaf nodes, and already talked about the need to add support for per interface statistics. Now, the flow label, as we talked about, may not be supported under vendor implementations, so we do have to look at that as an if feature if possible. Same thing, what happens if platforms do not support child policies, and instead schedulers and queues are configured directly under a policy. So we do need to look at that as a way to make sure that those are also if featured if possible. And that's it.
Any questions, comments? No? Well, we're right at the bottom of the hour. We're not going to have time for Eric's slot. I apologize. Eric, if you want to discuss on a mailing list to continue, that'd be cool. So that concludes the meeting. I don't know if you all were here yesterday, but this is Jürgen's last meeting as co-chair. So we wanted to just thank him for his efforts. Thank you. And we'll see you all in Prague. Thank you. Thank you very much. You're not. Yeah. Well, you know, done. So what do you do? Focus on the project. Yeah, this is time. This is time, you know. Surprising.